Hi everyone, my name is Susan Washko. I'm a graduate student at the University of Arizona and I study aquatic ecosystems. Today I would like to talk with you about sampling aquatic ecosystems. So the reasons we sample aquatic ecosystems are usually along the lines of answering ecological questions and aquatic biomonitoring. Biomonitoring is the act of observing and assessing the state and ongoing changes in ecosystems such as the biodiversity, types of habitats, and populations of different species. So, two big components of aquatic biomonitoring are water chemistry, or water quality, and aquatic invertebrates. And those are the two things I'm going to focus on today. Aquatic biomonitoring can also include looking at fish species, algae, aquatic plants, and sampling different types of habitats and looking at how many types of habitats there are in a specific ecosystem. But for today's lesson, we're just going to talk about water quality sampling and aquatic invertebrates. So I'm going to head out to the Santa Cruz River here in Tucson, and I'll show you a little bit about how we sample aquatic systems. See you there! Let's talk about basic water quality. So first, I'll bring your attention to temperature. This is a thermometer. We're using it to measure the temperature of the stream. Here we're doing it on the river's edge, but we would also take the temperature at different depths and in different habitats to get a good profile of the temperature within the river. It's important to understand the temperature because certain organisms have temperature tolerances that need to be met. Okay, next let's talk dissolved oxygen. Dissolved oxygen is also important because it's related to temperature. So the higher the temperature, the lower the dissolved oxygen. Here we're using a colorimetric system where we can take water and use a little chemical analysis and match the color to the chart you can see on the top of the lid, which indicates the level of the dissolved oxygen in milligrams per liter. Dissolved oxygen is used by aquatic organisms to breathe, so we want to be able to track that so we can say, yes, organisms can survive here, or no, the dissolved oxygen is too low. The next thing I'll talk about is pH. So the pH, as you probably know, tells us how acidic or basic the water is, which is also linked to species tolerances and growing conditions. Those are test strips there. And conductivity is also important. So conductivity is basically a measure of the quantity of ions that we have in the water. And it's important to keep track of that because conductivity changes can indicate increases in pollution because of changing ions. The ions are being brought in with the pollutants. So we keep track of that over time to better understand what's coming into the river or if it's stable. We would take the conductivity measurements by dunking the meter into the river. There are also meters for pH and dissolved oxygen, but I only have these handy-dandy stream-side chemistry kits. Another water quality component that we like to keep track of is turbidity, or the amount of suspended sediment clouding the water, or a measurement of how cloudy the water is. So you can measure this either with some sort of light reflecting meter, or you can take a sample of a known quantity of water and take all the water out of it and measure the amount of sediment that you have. And turbidity is important to think about because it keeps light from entering the stream, which could inhibit algae growth, and at the same time inhibit the hunting of visual hunting fish or other organisms from being able to survive because they can't see very well. And the last thing that I'll touch on is measuring the flow of the stream or the discharge. This is basically finding the volume of water that moves through the stream at one time, like cubic meters per second, for example. So the way that we would measure flow is create a transect across the stream and measure all those points across the stream, the depth of the water and the speed of the water. So then we can calculate the volume that moves by at one time. Then we'll do this in multiple areas across the stream and average. And the reason we would do that is because some areas of the stream are much wider than others, such as here compared to here. All right, let's move on now to sampling aquatic invertebrates. Okay, so we're going to use our D-net to take a qualitative sample of aquatic invertebrates. The first thing I'm going to do is find the opening of the net. I want the opening to take the downstream water into it. So I'll line it up like that, put it down on the bottom of the stream and kick. I want to kick that sediment into the net, and the stream water, because it's flowing towards the opening of the net, brings the insects into the net. I could take a quantitative sample by using a different kind of sampler, a Serber sampler, which has kind of a quadrat attached to it, and then I can quantify how many invertebrates there are per square unit of area. But for a qualitative sample, like if I'm just saying, I want to know generally what the species are that are here, so I can say if they're tolerant, if they're rare, I want a general idea of their abundances. That's what I'll do, is take a kicknet sample. Multiple kicknet samples are needed because we need the invertebrates from all potential habitats to create an entire species list and get a full idea of what's in the stream. You have to sample under the vegetation, in the deep areas, in the shallow areas, areas with sand, areas with gravel. If you're in an area where the water is not flowing and you don't have the advantage of it moving insects into your net, you have to take what's called a sweep sample, which is what I'm demonstrating here, moving the net back and forth along a 1 meter length. Catch you later, Santa Cruz.